This is actually called an identity equation because any value of x that I was to substitute in would give me a true example. So this actually has infinitely many solutions. And we're going to talk about why in a few slides. For now, just think if I was to say if x was 1, we'd get a true statement because 2 times 1 is 2 times 1. If x was negative 50, we'd get a true statement because negative 100 is negative 100. So just keep in mind that if I get a true statement, it has infinitely many solutions because I didn't solve for an individual x. So give me a couple slides and I will explain this further. So when we solve an equation in one variable, we're finding what value or values of x are in our solution set. So for example, for x plus 2 is 4, the solution is x equals 2 or 2. And that's because if I replace the variable with 2, our result gets a true statement. 2 plus 2, see I'm substituting in 2 for x, is 4. 4 equals 4, true statement. When we're solving equations with decimals, you can either leave them in decimal form, that's fine, but a lot of students prefer to go ahead and get rid of the decimals by multiplying by the power of 10 necessary to eliminate all the decimals, right? So here we have 4 100ths times x plus 6 100ths equals 1 and 46 100ths. So I would need to multiply both sides by 100 in order to get my decimals to cancel. So I would get 4x plus 6 equals 146. Subtract 6 from both sides. 4x equals 140. Divide both sides by 4. I get x equals 70 halves, which is 35. For this next problem, you can either go ahead and distribute or go ahead and multiply by 100. So let's go ahead and multiply by 100. I'm only multiplying the leading terms. That gives me 2 times 50. And that works because multiplication is associative. A times B times C is the same as A times B times C. Plus 8x equals 4 times 50 plus x. I have 100 plus 8x equals 100 plus 4x. Nope, equals 200 plus 4x. I subtract 100 from both sides to isolate my variable on the left. I subtract 4x from both sides to isolate my constant on the right. I get 4x equals 100, so x is 25. So if I was to divide by 4, 100 divided by 4 is 25. Now there are 3 different types of equations. So we've got conditional. These are equations that have one solution. Identity. These are equations that have infinitely many solutions, like that example a couple slides ago I told you we'd talk about. And contradictions. Those are examples that have no solutions. So why don't I go ahead and solve these 3 examples so we can take a look at them. If I have 5 times 2x plus 6 minus 2 is 7 times x plus 4, I go ahead and distribute my 5 to get 10x plus 30 minus 2 is 7x plus 28. I have 10x minus, I misspoke. 10x plus 30 minus 2 gives me 10x plus 28 equals 7x plus 28. I subtract 7x from both sides. I subtract 28 from both sides. I get 3x equals 0. I divide both sides by 3 because I can divide 0 by a constant. I just can't divide a constant by 0. And I get x is 0. This is only one solution. This is the only solution to this equation. That's why this is an example of a conditional. Next, let's compare an identity and a contradiction. An identity can have infinitely many solutions. An example of identity will have us end up with a true statement like x equals x or a number equals a number. So let's go ahead or 0 equals 0, right? So let's go ahead and take a look. If I have 5x minus 15 equals 5 times x minus 3, that gives me 5x minus 15 equals 5x minus 15. You can see now that both of these sides are equal and they're going to cancel out. If I add 15 to both sides, I subtract 5x from both sides, I get 0 equals 0. So that means there's infinitely many solutions and any value of x would lead to a true statement. That is different than a contradiction, which is going to have no solution. So why don't I solve that in red? If I have 5x minus 15 equals 5x minus 4, that gives me a little ahead of myself. That gives me 5x minus 15 equals 5x minus 20. If I subtract 5x from both sides, I get negative 15 equals negative 20. Can that ever be true? No, so there's no solutions. We use this, remember this is the symbol for the empty set. So let's identify the following linear equations as conditional, identity, or contradiction. So first thing I'm going to do is combine like terms on the left. So I get 3x minus 9 equals 3x minus 12 minus 5. So I get 3x minus 9 equals 3x minus 17. You can see if I was to subtract 3x from both sides, I get negative 9 equals negative 17. So this is a contradiction, which means it has no solutions, or the empty set. You can write it either way is fine with me. Problem 2, let's go ahead and distribute. I've got 6x plus 3 minus 2x minus 2x times negative 2x is plus 4 is 5. I combine like terms. I have 4x plus 7 equals 5. Subtract 7 from both sides. I get 4x is negative 2. I divide both sides by 4. I get x is negative 2/4 or negative 1/2. Always remember to simplify. And this is a conditional because it only has one solution. Last but not least, I've got 6x minus 12, which I can't simplify any further, is 6x minus 12. Shock and off, I add 12 to both sides. I get 6x equals 6x. If I divide by 6, I get x is x. This is a true statement. So there are infinitely many solutions. And that means that this is an identity.